wouldn't notice it at first. The sky would look the same. Birds would still fly. Traffic lights would still blink red and green. But somewhere in the span of a single heartbeat, the ground beneath every living thing on Earth would stop moving at over 1,000 kilometers an hour, and nothing else would. Within the next 5 seconds, almost everything humanity has ever built would begin to fail. This is not science fiction. This is what physics says would actually happen. Right now, you are moving. Not walking, not driving, spinning. If you live near the equator, you are being carried through space at roughly 1,670 kilometers per hour, faster than a commercial jet, at cruising altitude. You don't feel it because everything around you, the air, the ocean, the buildings, your own body, is moving at exactly the same speed, in exactly the same direction. It's the same reason you don't feel the motion of an airplane once it levels off. Relative to everything around you, you are still. But what if that motion simply stopped? Not gradually, not over years, but instantly, for 5 seconds, before starting again. This is a thought experiment, not a prediction. Nothing in known physics could actually halt a planet's rotation this quickly. But by asking the question seriously, and following the laws of motion wherever they lead, we can understand something we almost never think about: the invisible force that holds our entire civilization in place. Let's begin the countdown. The Earth's crust stops. Instantly. But the atmosphere doesn't. Neither does the ocean. Neither do you. This is the law of inertia, first described by Isaac Newton nearly 350 years ago. An object in motion stays in motion unless acted upon by an outside force. The ground has just been acted upon by an impossible force. The air above it has not. At the equator, the atmosphere is still moving at 1,670 kilometers per hour, because there is nothing yet to slow it down. That's faster than the most powerful hurricane ever recorded. It's faster than the speed of sound. In the same instant, every unanchored object on the surface of the planet, cars, trees, people, oceans, keeps moving at the speed the ground used to be traveling. Only now, the ground beneath it is not. The wind arrives first. Not a breeze. Not a storm. A wall. In New York, sheets of glass shear off skyscrapers as a supersonic wind front tears down Fifth Avenue. In Tokyo, the same wind flips cars like playing cards. In Dubai, sand from the surrounding desert is lifted into the air in a single violent sheet, scouring paint from every surface it touches. This isn't wind in the way we understand it. It's the atmosphere itself, still traveling at orbital ground speed, scraping across a planet that has suddenly slammed on the brakes. Meanwhile, every person not anchored to something solid is thrown. Not stumbling, thrown, at highway speeds, in the direction the Earth used to be spinning. A family eating dinner never sees it coming. One moment they are passing dishes across a table. The next, every window in the house explodes inward as the pressure differential outside becomes catastrophic. The oceans begin to move. Water has no rigid structure to stop it the way land has. The Pacific, the Atlantic, the Indian Ocean, all of it keeps traveling at its old rotational speed, sliding across the now stationary seafloor like a tablecloth yanked out from underneath the dishes. The result isn't a wave. It's closer to the entire ocean basin surging in one direction at once. A phenomenon with no real historical comparison, because nothing like it has ever happened. Coastal cities from Shanghai to Rio de Janeiro would see the sea itself rise and advance inland, not as a tsunami triggered by an earthquake, but as the direct result of water refusing to stop when the ground did. In the Amazon rainforest, the canopy, normally a windbreak, is stripped bare in seconds. Trees with shallow root systems, built to survive storms, but never anything like this, are uprooted by the thousands. Now the built world fails. Bridges are engineered to flex within a narrow range of forces: wind, traffic load, thermal expansion. They were never designed for a horizontal force equivalent to sustain supersonic wind shear. Suspension cables snap. Overpasses buckle sideways. Airplanes in flight face an even stranger fate. A plane doesn't fly relative to the ground, it flies relative to the air around it. But that air is now moving at a wildly different speed than the ground beneath it, meaning the reference points pilots rely on become meaningless in an instant. A pilot cruising over the Himalayas watches the horizon vanish, swallowed by walls of cloud and debris moving faster than the aircraft itself. Some planes, still airborne when the event begins, are torn apart by turbulence beyond anything in aviation history. It happens too fast for a distress call. Trains, among the few vehicles rigidly locked to the ground via their rails, briefly become some of the safest places on Earth, until the rails themselves, and the ground beneath them, are struck by the same debris-laden wind tearing through everything else. Power and communications start to go dark. Electrical grids depend on synchronized generators spinning at precise, matched frequencies. The violent physical destruction of power lines, substations, and transformers, torn apart by wind and falling structures, begins cutting off electricity to entire regions within seconds. Not because the grid knows the Earth stopped, but because the wind alone is enough to sever it. Satellites in orbit are the strange exception. They aren't attached to the Earth's surface, they are held up by orbital velocity, independent of the ground below. For a satellite, nothing has changed. It keeps circling exactly as before. But the antennas and ground stations built to talk to it are being shredded in real time. A scientist at a tracking station watches the incoming data go from a clean signal to static, and understands, just before the monitors go black, that this is not a technical failure. This is the world outside breaking apart. In the Sahara, dunes that took centuries to form are stripped and redeposited hundreds of kilometers away, the landscape rewritten in real time. In Antarctica, ice sheets several kilometers thick barely register the wind, but the atmosphere screaming across their surface is enough to flatten research stations that have stood for decades.